Thank you everyone for joining us today on our webinar for owning the value chain of additive manufacturing for mass production. My name is Alyssa Welch and I am the Global Head of Marketing for AMT. Just before we get started, I'm going to give you all a quick overview of what we can expect from today's webinar. So to start off, AMT and OECHSLER will be giving brief company introductions and an overview of our partnership. And then OECHSLER will dive into their product portfolio and their core focus of additive manufacturing, overviewing their current manufacturing methods and some of the challenges that they are facing. Then AMT will discuss how to overcome those challenges and scale for mass production. Followed by the last point will be discussing the future state of additive manufacturing. Now we will have a dedicated Q&A session at the very end of this webinar, but please feel free to utilize your Q&A function throughout the webinar to submit your questions and we will answer them as we go along. A recording will be available at the end of this webinar afterwards. And now without further ado, I'm going to let our presenters take it away.
Thank you, Alyssa, and welcome, ladies and gentlemen, to this webinar. We're very excited to be holding this today with our partners, OECHSLER. My name is Joseph Crabtree. I'm the CEO and founder of AMT, or Additive Manufacturing Technologies. We'll explain a bit about our respective companies in a minute, but just a little bit about my background. I founded AMT in 2017. Previously spent a decade in traditional manufacturing before that, in various roles, engineering, operations management, and sales and marketing. And really my background, my sort of trade is material sciences and engineering. So bringing quite a unique perspective to 3D printing and how we scale into a manufacturing technology. And as I said, thank you very much for attending. We look forward to presenting this to you today. Please feel free to ask questions. We'll try and answer them as either we go through or at the end of the webinar. And I'll hand over to Andreas now.
Good afternoon to everyone from my side. Thanks, Joseph. My name is Andreas Knöchel. I'm working right now for OECHSLER in the role of being responsible for our program management, additive manufacturing. Our main role is from the very first beginning, thinking about product idea, how can it come to market and what could be a benefit. And for sure, the whole team is a desperate need of the full value chain. A little to my background, I'm also coming out of the mechanical engineering. In the past, fully dedicated to automotive, but meanwhile, since I joined OECHSLER 7 years ago, it's about new technologies, launching new products, and since 5 years within the additive manufacturing.
So hi everybody, my name is Matthias, last name Weisskopf. So I'm with OECHSLER since roughly 16 years, and as you can see, being responsible globally for all R&D activities of OECHSLER worldwide. So what does it mean? Of course, additive development as a separate unit, but also mechanical development, electronics development, everything. What you will see later, what is needed for our product development in general. My background is being a mechanical engineer, and being honest, until 2016, my link to additive was not that good. But since that, I brought it into OECHSLER and mainly increased all the activities, also everything what Andy is managing right now.
Thank you very much. So just very briefly, we're going to give an overview of our respective companies. We're going to start with AMT first. So as I mentioned, I'm the founder and CEO of AMT. What do AMT do? Well, we focus on everything after the printer. So we don't print parts, but what we do very well is finish parts. And we've developed a full technology stack of hardware which we call Post-Pro. And in essence, that enables you to transform an as printed part into something that looks, feels, and behaves like a traditionally manufactured part. And we automate that entire process chain from printer through to final part. As I said, we're formed in 2017, headquartered in the UK, in Sheffield. We have extensive research and development facilities and manufacturing facilities in Veszprém, in Hungary and mainland Europe. And we also have a 20,000 square foot facility in Austin, Texas, which serves the US market. So We're a global company, over 200 installs to date of our both of our individual modules and our end-to-end systems. And we're present in approximately 28 countries globally. So, we're a VC-backed company, raised about $25 million to date. But in the last half decade since starting the company, we've really grown to become the market leaders in our core technology, which is chemical vapor smoothing, the ability to transform that part into a real life end-use part. And also the thing that we'll be talking about today, which is the end-to-end automation of the full process from printer to part. So yeah, very excited to be talking about this today. Very excited to be bringing to you this new technology that we've developed with OECHSLER. And without further ado, I'll hand over to OECHSLER to introduce their company.
So I'm going to give you a short info about OECHSLER. As we are talking today about additive, you need to know that OECHSLER is not only linked to additive technologies. Our core business is injection molding. So we were founded in 1864. Until 2004, we were a typically Franconian mid-sized company, below 100 million euro turnover. You see a big growth. The figure is roughly 400 million euro with a clear focus on automotive, but also innovative solutions and a small portion of healthcare, with a global footprint that was set up in the last 15 years. So 7 production sites globally: China, Vietnam, Romania, Mexico, and 3 sites in Germany. One of that 3 sites in Germany is totally dedicated to additive. We have roughly 3,000 employees worldwide, and we are still 80% family owned. What is important as well is that everything what we do is mainly linked to development. So we are not a pure manufacturer. Often it has to be also a development by OECHSLER, either on process side but also on product side.
Thank you. So just before we launch into the presentation, we just wanted to describe a little bit about the partnership between AMT and OECHSLER. And as we previously mentioned in other public settings, is we believe that it's through partnerships that we can really achieve this vision of end-to-end industrial additive manufacturing. And OECHSLER and AMT have chosen to partner together to basically deliver a full end-to-end automated solution that allows you to take any part and print it in high volumes, suitable for end-use applications, whether that be automotive, whether it be consumer, or other critical industries. Now, initially, the partnership and the development is going to focus on HP multi-jet fusion printers and the associated materials with that, specifically on complex lattice structures and flexible polymeric materials. But really, we still have a very agnostic approach between the 2 partners, and we'll be developing systems that are agnostic in terms of printer technologies as well. This is something that's happening right now and has been happening for several months previously. We expect to have the first full end-to-end systems combined with printing technology in approximately 1 year's time. And we believe between us, this is the first time that we will have truly enabled 3D printing at scale for high volume applications. There will be more information on the partnership coming in the coming weeks and months, so stay tuned for the press release and some other information that we'll be releasing. But needless to say, we are very excited about the partnership, and we look forward to discussing more with you in due course. Matthias, Andreas, do you have any other comments on that?
Yes, perhaps it's important to understand for the audience that how OECHSLER and AMT came together a certain time ago. So OECHSLER had a huge automotive project, and we had to make a technology shift from another printing technology to a powder technology. And this was where mainly Andy, me, and Joseph were connected. And since that day, I would say we really worked together, of course, on the challenges we had in the daily business, but with a clear target, what is needed for the future, as everything what was and what is still available on the market didn't fulfill our requirements. So it was from day one really an open communication and partnership for the same target, as nobody, neither AMT nor OECHSLER, was able to handle it alone.
Great, thank you. We're now going to deep dive a little bit into our respective companies' product portfolios and core value propositions. So, OECHSLER, please.
So as I mentioned, OECHSLER is not only manufacturing additive products or products with additive technologies. Our core focus are, you can see on the right-hand side. So the most known product of OECHSLER is an actuator called electronic parking brake. So an actuator sitting directly on the braking saddle, where you can see a lot of plastics, but also mechatronics components like motors, gear parts of metals and so on inside. Also in the driver assistance field, so radar systems for cars, for autonomous driving, and other products as well. On the right-hand side, on the bottom, you see the sporting goods field. I think we don't need to mention the Adidas midsole, but this is definitely also part of our manufacturing portfolio. And important is also what I mentioned in the beginning, that it's often linked to development. And this is also something what is important, and I think Andy will go for this in the next slides. Additive is only a technology how to manufacture a product. So we have a huge variety of technologies to manufacture different products we develop. And there's not a single technology that is serving all the needs we need at OECHSLER. It can be injection molding, but it doesn't need to be. It can be printing, but it doesn't need to be. You have to offer a huge variety and therefore also a huge variety of post-processing solutions. And that is mainly one of the reasons why Joseph or AMT and OECHSLER started this program. So Andy, you can hand over to the next slide.
Yes, so as Matthias mentioned, OECHSLER, we are a productive company using additive manufacturing for regular production, I would say so. I think that's also the main difference between OECHSLER and a regular service bureau or a service partner. We are not the regular printing farm who does prototypes, 1-2 parts, and then never seen again. We are really going for serial production on a long term, meaning the product, is going quite a little while. Therefore, from a printing fleet, as we do serve kind of all industries, you need to be able for sure to serve also volume. Meaning we are running right now 150 printers in serial production plus development printers. We every time have 1 or 2 not yet available serial equipment in development, just to be ready for the next topics. Our turnover in parts is around 1.3 million parts per year. And here it's really a continuous project work and production, meaning bigger projects, really also projects with 6 figures when it comes to the customer needs. For sure, you see here now 3 technologies. Even a liquid version, which is not the focus for today, but this was one of our earliest technologies we did bring into serial production. Now, today, it's really the focus for the HP technology and MJF, and I think that's really the key. We are looking not only in mass manufacturing. For us, it's the complete value chain. For liquid, we did it already 5 years ago, meaning printers is one topic, but really the complete environment, the equipment you need for everything is not available or was not available at this point of time for a scaled production. So we are going here for the full industrialization. And this time now for MJF, we're partnering with AMT for really going for complete post-process equipment, including or starting already with the printing. Yeah, so not a separate version. And why do we need it? I think it's clear OECHSLER cannot work with the standard equipment. Why? Our focus on 3D printing is also not only just the regular type of housing or mechanical technical product. Yes, we are doing that also, but a huge focus is on lattice. meaning structures which do give additional benefit into the product. And when you are going for lattice, everything else changes. Meaning, if there is some equipment now available, it usually doesn't fit to lattice. But before we're looking into the products, maybe Matthias can give you a short overview what we are really doing in lattice and why it's for us so beneficial and why we can bring, I would say, more benefits to a product as the usual one.
Exactly. So when we started in 2017 with the additive topic, we clearly evaluated the potential, and it was the result was that we don't want to replace, or that it doesn't make sense to replace injection molding. So we have more than 200 injection molding machines worldwide, perhaps even more than 300. So injection molding is a process that is well known and that can be also for small quantities really cheap. So what does it mean? You need to offer products that offer new possibilities that a classical manufacturing technology cannot offer. And this is something where we started with the lattice topic. So lattice doesn't need to be a flexible material. It can also be a rigid material, but in general, it is a special version of, how to say, structures. And when we started in 2017, we realized pretty fast that there is also no software solution on the market to generate those lattices. It's almost the same than the link to the post-processing or to the manufacturing technologies. There is, of course, software generating lattice, but we need a linkage to, for example, mechanical properties of a product. So, and a customer in additive doesn't want to have 5 different correction loops until he receives the first part that is somehow managing his requirements. You need to hit, hopefully in the first shot, the requirements the customer wants to have. And therefore, we evaluated a huge database and a whole software solution how to generate those lattices. So based on mechanical properties, we can generate those lattice structures pretty fast, and we can print those components or products with the performance they need. And meanwhile, I would say we are able to hit it in the first shot. But the specialty is that, of course, every product is different. And this is the biggest challenge for the process technology in total. What does it mean? You need to clean those lattices. You need to get rid of the powder. If the quality of the struts is not good enough, you have thousands of those struts, and even a small deviation of the CAD file to the real product has a huge impact on the performance of the product. So that is the reason why we need end-to-end means starting with development until the last production step and linking also the results, also the quality inspection, as the more products you produce, the better the database for your product development is. And Andy can give you now a short overview about the products we are talking about.
So what you see here is I would say a small variety of products, but a wide range of industries. Meaning, OECHSLER sure is working a lot in the field of automotive, but in additive manufacturing, we are almost completely open, I would say. Why? Because we do see here the possibilities and opportunities really to bring different functions into different products. What you see here on the left side, it was one of the starting projects. It's the automotive seating. One seat project is already live available. It's a Porsche sporting seat. The complete inside is made out of additive manufacturing lattice components, meaning we took the form out, brought new parts in it, and here you can completely adjust the hardness like the driver wants, or even have different seats available depending whatever the driver wants to have, soft, hard, middle, medium. But also for sure the ventilation, the height is different, meaning we do need less volume. In the weight direction, by saving less volume, you can save a lot on the rest of the seat. So you see, it's not only about a new technology and something new going into a product and the customer only takes it because it's new. No, there is really coming more and more benefits into the product, especially in that serial production or available serial production. We definitely use the regular printing, but also the complete technology, meaning going for printing, going for cleaning, going for vapor smoothing, even for coloring. Because in this case, yeah, you have optical visual parts and the customer just wants to have a smooth surface which has the color of the car. Transition set, it works definitely in office seating or even gaming seating. And we, in the middle area, what we are looking for the furniture industry, which is completely new. No one ever printed before cushionings for the furniture industry. For the fixtures, for the frames, yeah, you see it design-wise here and there, but we are really striving also to bring in comfort and additional possibilities into these products. When it comes to a complete different area like consumer goods, in the backpack, there are meanwhile also even two available or known in the market from our partners, or in this case customers. We also did go here for complete backpack to allow air ventilation, to allow reduction of pressure points in the lower back by bringing in this special material, which is the TPU from BASF. You also bring in the one material factor, meaning there is a possibility of a real recycling after the lifetime of the product. And for sure, there are additional benefits, like on the right side, you could go into the orthotics, into insoles, which we are doing. You can go into pure design, packaging, showcasing of, in this case, for example, it's a liquor bottle, or even for perfumes, you can fully use it. And now, what do have all these products in common? In this case, I focus today for the flexible components because it is the TPU material, and that's a common topic. All parts are made out of one material in this case, which is good. Material performs very well, but we do have one big issue. And the issue in this case is TPU and post-processing as of today does not really fit together. PA12, for example, likely a couple of you guys are well aware of 3D printing. PA12, rigid components. The post-processing, the cleaning is pretty simple because the material gets out pretty fast. On TPU, it does stick very well to our lattice components because it's inside everywhere. And maybe, Alicia, if you would please slide to the next page.
Andy, not to interrupt you, but there was a question, and I think it's right to answer it here. There was a question of an example of a lattice product of a rigid material. I cannot mention the product itself, but I can describe the functionality. It is a crash element. The normal standard product is a hybrid part, complex part of plastics and metal combination to absorb a lot of energy in the crash case. And you can reach the same result just by generating rigid lattices, but you save roughly 70% of weight and a lot of space. And it is not used in mass production because it's really a challenge to convince customers changing and challenging the existing technologies and the existing product development techniques. But those are examples, for example, for a rigid lattice product. Hopefully it is answered. So Andy,
okay.
Sorry.
Coming back to our, let's say, post-processing issue, what you see here, for sure, it somehow looks like the regular depowdering method you're using all day long. On the left side, it's still packed. You take it out of the printer. You see it already, two hands, meaning everything manual. Unpacked, especially on our lattice products, everything is completely full of powder. Still after the air blasting, it's not clean at all. So after glass bead blasting, it's pretty good. But sure, it's a big, I would say, benefit and the The visuals does come after vapor smoothing. And now as you see the picture, especially on the middle one, that's a big difference when you're going for TPU. TPU does stick everywhere, meaning it sticks to the lattice. Even the elements which go out of the lattice is not powder. It's kind of powder which is stuck together, kind of agglomerate. So meaning you cannot just put it in a machine and the machine is shaking it, turning it upside down or does whatever it does. No, you need to carefully go through all these working steps. TPU is unpacked in a hot way, meaning everything is very smooth. You can damage it quite a lot. And unfortunately, for us in this case, there is not a real dedicated equipment or technology available on the market, which can really fulfill all these needs in a, I would say, pretty easy way. For sure, we have our manual technology, which does the work pretty well. But really to go even in a more productive way to even bigger scale up, we do need something new, and that's really what's it about today. And within the partnership OECHSLER and AMT, that we are getting here a solution to the table, which does the job faster, easier, more simpler. And I think the next slide will show us, not only that we need it for scaled production. What you see on a process flow cost scenario, the machines, sure, they do cost quite a money, but by having everything handled from step 1 to step 2, having everything controlled a lot, being so precise, being carefully everywhere, you do see almost 2/3 is the labor costs. And when it comes to our customers and products, I would say for sure within the top 2 questions, one question is, why is it so expensive? How much does your product cost? That's why we really have to tackle it on that side, to bring 3D printing in a more simplified costing structure. And on top of that, but I think later on we come to that, there will be not only a costing topic, there will come quite a lot of other benefits when we solve that issue.
Yeah, and in parallel to this, it's also, of course, the variety of products. So it's a different if you have a small product or if you have huge products, if you have a vapor smooth product or not. So the process steps are different and they are not leveled. So what does it mean? You need to have a flexible production solution, and just by multiplicating different single machines will not solve the issue. Even when you put some interim automation inside, it is also would only be a one-time solution. So it needs to be a flexible solution. And even when Andy mentioned the post-processing, we all shall not forget the pre-processing, or what happens after the post-processing, reusage of material, being prepared for the next print jobs. Of course, a 24/7 manufacturing that it is efficient. That is the challenge.
Thank you, and a great summary of the current status quo, and highlighting that even with machines to automate the manual workflow, it still doesn't suffice in terms of producing the full end-to-end scalable production. So with that said, we're just going to talk a little bit about what we're doing in terms of the partnership. So this really is about the full end-to-end automation of the process flow. So we don't just mean individual modules which are not scalable. We mean the complete integration of all of the key process steps. Those process steps, as Andreas and Andy was saying, was unpacking, the removal of the part from the printer, the cleaning, which is very complex on lattice structures and this flexible polymeric material as well. And once we've done all that cleaning, then there's aspects of recycling and powder management that we need to deal with as well. Once we come out of that, though, we need to deal with the surface finish. A lot of the applications we've discussed and shown are consumer or critical aesthetic applications which need a very good surface finish, i.e. to be smooth. and or to be colored to a certain color hue or matched to a certain specific coating, for example. So really this whole process isn't just about removing the part and cleaning the part, it's about how we functionalize the surface, how we improve the surface, and how we automate the full end-to-end workflow. So this is in essence, what we're doing with OECHSLER. We mentioned before, it's not good enough just to add machines. So, you know, if you've got a number of printers, we can't just add more and more post-processing modules. So AMT and OECHSLER have developed a fully integrated solution that allows you to truly scale additive manufacturing. This is a representation of the cell that has been developed. We'll be releasing more details in due course over the coming months. But in essence, I'll just walk you through the workflow from a fairly high level point of view at the moment. This is a scalable solution. What I mean by that is that it works with any printer platform, it works with any materials, and it works with any number of printers. Our ideal number of printers per cell, per manufacturing cell, is around 10 printers, and we classify those as 10 industrial printers. In this case, it's HP Multi-Jet Fusion 5200 platform. So we're talking high volume industrial printer production and a high number of parts serving these cells at once. We then need to manage those printers. So in essence, we're taking the build beds using autonomous guided vehicles. We're taking the build beds and docking them into our system. So think of it like a bit like the space station. You know, you can dock certain capsules into it. That's exactly what we're doing with our system. We're taking any printer build unit, docking it into our fully turnkey modular solution. We take the build beds, we remove those powder cakes, i.e. the parts with all of the powder still stuck to them. We recycle the powder if appropriate. Now, I know that depends on which materials you're using. We can then refill the cartridges as well, and those cartridges can be used then for further manufacturing and further printing in a truly lights out 24/7 operation. When we've unpacked the parts, we then need to clean them. And we need to clean them because we need to remove all of that remnant powder. And it's not until we have a clean part that we can actually do something in terms of additional or secondary post-processing with it. So once we have those clean parts, we then have another challenge, because, you know, humans are very good at doing manual processes. Humans are very good at sorting parts, picking parts, placing parts on racks for processing. But robotics up to this point is very challenging to actually do that, you know, in terms of the vision systems, the automation, etc. And we've now developed systems that actually allow you to sort those parts. So to the point that was made earlier, is that this could be a very small consumer part, or it could be a large industrial part. It could be a very complex hinged part. We need to be able to identify those parts, understand which part is going where, but more importantly, understand what secondary processes need to be done to each part. So it may be that the part just gets cleaned and that's it, no further processing. It may be that a part needs to be cleaned, chemically vapor smoothed and or colored, or it might just need to be colored or coated or go to a tertiary manufacturing operation. So really think of this as a sorting station, a part vision, automation and recognition system that allows us to control and guide the multitude and the thousands of parts that come off these printers. Not only do we able to identify and process these parts in accordance with the requirements, but we're creating a digital twin. And what I mean by that is we have the 3D part model. Obviously, we have it for the printing process. And by using that, we can tag the data in that so that we can actually define the post-processing processes required, but also retain the traceability through the process. And as we mentioned before, there's a lot of industries that are potentially accredited. You know, we talked about automotive, there's consumer, there's medical, where you need to retain data, you need to have full traceability of the part. And that can become quite complicated when you're dealing with multiple build units, multiple printers, and multiple post-processing steps. So that's a really critical part of the process. But when we talk about automated cells, we really do mean that. So this is really 24/7 lights out automated manufacturing, from printer all the way through to part, with very limited human intervention. And to achieve that, we do need to be inspecting the parts in an autonomous manner as well. We need to be quality assuring those parts to make sure, for example, the parts don't have any remnant powder in them, that if you're chemically vapor smoothing, that those parts look, feel, and perform like they're supposed to a specification typically. And if you're coloring or coating the parts, the color is the color that you're supposed to be coloring it. And as you all know, 3D printing up until this point does have variability. And really, as we mentioned before, one of the goals is not just about cost reduction, but about reducing or increasing the repeatability and reproducibility. So we can increase the CPK, so the manufacturability of these parts, we can increase the repeatability and reproducibility, and create a true manufacturing process from printer all the way through to parts. So there's a lot of proprietary technology going on here, and we can't divulge too many details right now, but as I said, over the next coming months, we'll be able to divulge more. But it's tremendously exciting, not only for our two companies, but for the industry as a whole, in terms of what is now accessible and potentially available to the industry and to potential applications in the future. Next slide, please. So just a little bit about, I mentioned that this isn't just about cost reduction. Yes, it's important to get the part at the right price. And by doing that, it enables us to scale additive manufacturing. It then becomes competitive with other manufacturing technologies and makes the buyer or the customer's decision that much easier when we can produce parts at scale at the right price. We mentioned some of these benefits before, but we are talking about scaling manufacturing here. So tens and tens of printers, millions of parts. And we talked about this digital twin concept, that we're not just printing parts and not knowing what's happening or not knowing how they're being traced. We're creating digital twins. We're integrating that with the manufacturing software of the facility. We're integrating that with the printer software. We're integrating with any downstream manufacturing processes. So this truly becomes a fully integrated process that achieves consistent, reliable quality every time. Andreas, do you have a few words on this?
Definitely. When it comes to the quality, you saw a wide range, automotive to consumer goods. And meanwhile, everyone in the past, I would say, yeah, consumer goods, let's just print it. No, the customer expects good quality, and not only good, it must be on the same consistent level. Maybe not in every detail, but it's really very similar from the part quality what needs to be achieved. Even if it's at the end a shoe and not a car seat, yeah, it still must perform physical and optical wise that the customer is or that the customer does like it and wants to come again. So quality is really one key. Sure, we do have right now a good quality achieved, but reproducing it over, as Joseph mentioned, millions of parts, you have to take care much more, as if you would be sure the machine, the process is running consistent all day long. Yes, there are coming just additional benefits by doing the processes in a certain way we are approaching.
And I would say a huge topic, not today, but for perhaps tomorrow, is one vision of additive is definitely a decentralized production, producing the part where it's needed. Printing perhaps is possible, but if you don't have a standardization on a quality level for the post-processing, how do you want to utilize the potential of additive being a decentralized production technology? So you need to develop those post-process or process technologies that you can achieve the right quality wherever it is needed.
Agree. Thanks for your input on that. And as we mentioned, not just about cost, there's all these other variables that we're considering, and we're hugely excited to be introducing this to the market and to the world. So next slide, please, Alyssa. So just really finally in conclusions and summary. So, I mean, thank you all again for attending and thanks for your questions so far. But really just in summary, so, we mentioned at the beginning that partnerships are key. So neither party could do this on their own, and it's by combining our unique skill sets that we're able to achieve what we're talking about today. And we really value the partnership, and we believe that through this partnership, we truly are going to deliver the world's first end-to-end production system that's scalable and producing millions of parts, end-use parts at scale very soon. And as we mentioned, yes, this is about replacing manual processes. It is about automating processes. It is about driving down costs, but it's so much more than that. It's about, maintaining the quality, increasing the repeatability and reproducibility, and producing a true manufacturing technology, not just a technology that's 3D printing. We've divulged some details here. We've not given you all of the magic sauce. We'll retain that for ourselves, but we will be able to divulge and discuss further details, further applications that we're developing in the near future as is appropriate. And we'll discuss those results publicly at an appropriate juncture. But really just to leave you with a thought, we're now looking at real life applications, real life production, which is super exciting. And that's been enabled by this partnership between OECHSLER and AMT. So Andreas, Matthias, anything to add to that?
From my side, the project team is fully excited on that because the project lead is also running here in the additive manufacturing team. So everyone is really looking forward to it and are already working on it. So yeah, it's definitely a great project, not only for the outcome for our products, also from the team setup. Yeah, the mix between the two partners. Definitely a project we will remember quite a while.
Yeah, and from my end, of course, as I'm sometimes or very often very critical, a lot of new technologies and a lot of new companies rise in the additive field. A lot of people promise, but in the end, on the processing side, not really a lot happens. And if you want to develop new products, you need to have those solutions on hand, because without those, you cannot scale and you cannot produce those products in a huge quantity. So it is a must-have for scaling. And as OECHSLER is a manufacturing company, we don't earn our money with developing fancy products that were produced one time, right? So we want to scale production and produce huge quantities and growing the business. So it is a chicken and egg discussion, of course, but this is definitely an important portion of it.
Great, thanks for your input so far. And I think we're just on time. So Alyssa, next slide, please. So again, thank you everyone for attending today, and thanks for your questions so far. We do have a few more questions that we're going to go through here from the audience. So the first question is, would the new end-to-end solution also work for SLS with minimal changes? So absolutely. So we are agnostic in our approach. As OECHSLER talked about, they use multiple printing platforms. They talked about Carbon, HP, EOS, for example. The system we talked about today is predominantly focused on powder-based printing technologies. In this case, it was TPU and lattice structures. But absolutely, that the system can be flexible to change to other printing technologies, other products, other materials. And that's key, because not all applications are going to be lattice structures and TPU. We need to retain the flexibility. We need to be agnostic to both technologies, i.e. printer technology, and also the materials and the powders.
For example, Joseph, I think this is something what we can mention. For us, it is also important, for example, to just bring in parts of a different technology into the quality inspection. So it is possible that you just use the quality inspection of the system for a different printing technology where you have a total different processing line, for example, for liquid systems. Yeah, so we want to have a flexible solution as you have it, for example, in injection molding. An injection molding machine can handle different materials. It can be automized, it can be manual driven, it can be linked to other machines, whatever. So in a real production environment, it needs to be a flexible solution.
Yeah, and just a comment, there's a question asked about photopolymers as well, just linking to that part, specifically about support removal for photopolymers. So supports are required for photopolymers, and that is a post-processing challenge, right? You need to remove the supports after the part's been printed. So just to reiterate, this cell has been designed for powder-based printing technologies at this point, but there's absolutely no reason why, as was just discussed, elements of that can't be used for photopolymers or other printing technologies. But really it's applications driven, right? There needs to be a commercial case, there needs to be a logical business case for producing a certain system for a certain printing platform. And if you split, you know, photopolymers or thermosets and thermoplastics, there are unique challenges with each, and we just need to be mindful of that as we look at those. There was another question on the automation, which was specifically about Mitsubishi robots. Are we using Mitsubishi robots? So we're not commenting exactly on the specific automation technology that we're using, but there will be a number of different automation technologies. For example, robotic arms or AGVs used. But that's not really the key part. The key part's actually how you utilize existing off-the-shelf robotics, whether it be from Mitsubishi, KUKA, or whoever else, and then utilize end arm effectors, vision systems, and then combining that all together to pick, place, sort, visually inspect, identify, and manage parts within the system. So it's not necessarily about the robotics that's the clever part, it's about the overarching software architecture, the ability to handle 3D printed parts and manipulate those. And the challenge with 3D printed parts is that every part potentially can be different. So that's, again, a complexity that, let's say, automation of injection molding doesn't suffer from. You know, it's relatively easy to automate injection molding. So it's a challenge, but it's one that we believe that we've cracked. Just a couple more questions. There was a comment made about costs and repeatability and reproducibility, and I just echo those comments that this is exactly, you know, what is required for the industry to be able to scale in terms of 3D printing, and also scale applications in terms of volume and making it cost efficient, throughput efficient, et cetera, et cetera. Sort of semi-related is a question about the concept. How was the concept arrived at? And, you know, really, if you think about this logically and look at traditional manufacturing has been around for many, many years, and 3D printing has been around for at least 20 years. But it's not until fairly recently that end part production has been the focus of 3D printing. You know, previously in Additive 1.0, it was all about low volume parts and prototyping. And at that point, the focus was all on the printer and the materials. You know, as long as you could print 1 or 2 parts or 10 parts or small production runs, it was fine. And manual post-processing or finishing was acceptable because you literally had a person finishing the part to the desired standard. But as we enter Additive 2.0, this new era of end-use parts for high production and scale applications, it just doesn't make sense. And you now need to treat 3D printing as a true manufacturing technology. And as we've discussed before, you know, be able to reduce the cost, increase repeatability and reproducibility. And therefore, the only way is automation, and the only way is to have a full end-to-end system. So it's kind of born out of a necessity, a real challenge that the industry has. And we believe that by combining forces in our two companies and also with the printer manufacturers, we are.
Yeah, but Joseph, I think we can say how we came to the concept. It was an intensive work over a month, bringing different teams together, really. Starting from the product development guy to the process owner to the machine development people from AMT. So collecting all requirements, defining must-haves, defining nice-to-haves, defining the vision of the future, not only living in the now, but also asking what is needed tomorrow. I think we can say that this was mainly a year's time collecting all the requirements and really defining a concept. So a huge part of the work was before starting the solution, right?
And I think that's a really important point, is that without these partnerships, this just isn't possible. And, you know, it's by combining forces that we can enable the respective parties to do this. But I also believe that, you know, again, if you look at the applications, for example, automotive, the requirements from a quality perspective, you know, to make sure we're getting the right parts, etc., they're non-trivial, and we need to make sure we get this right. This is ultimately a manufacturing cell and manufacturing system. And, I think, historically in 3D printing, there's been a lot of hype. There's been a lot of people talking about the factory of the future and, how a concept could look like. But this is now really happening, and we're really doing this, and we're really excited to be doing this. And as I said, we believe it's a world's first. So yeah, we're excited to share more details in due course. I think that might be it for the questions, unless anyone's got anything else. Okay then, well, again, thank you all for the attendees. Thanks to Alyssa for moderating, and thanks to Matthias and Andreas for participating from our partners at OECHSLER. Again, we're very grateful of the partnership. We're grateful for you all attending today and taking your valuable time. And if you do think of any questions afterwards, then feel free to email us directly and ask a question, or watch the webinar at your leisure. Thank you very much, everyone. Have a great day.
Thank you all.
Thank you.
Have a good one. Bye-bye.
Bye.